on the bridge you can get by looking at all the smartphones of thousands and thousands of people going across the bridge every day. This is actually data we collected with Uber and with the Uber app of all the Uber cars going back and forth on the bridge. And here is the paper. If you're interested, you find all the papers, by the way, on our website. You can download it from free if you want to look at the mathematics. Now, I'll give you another example. It's a paper that will be published in a few weeks, and that actually looks at optic fiber in our cities. Our cities are filled, they're full of cables of optic fiber, and it turns out that then if you actually put a small unit and send a laser and look at backscattering, you can actually use data that is very precise sensors over the entire city. So this becomes a great way to better understand dimensions of the city. If you're interested, you find the paper for something is printed, but this is going to be published in Nature Communications in just a few weeks. Or the other thing we can do in cities is actually collect data from cities. And we can use our own sensors to do that. Look at this. This is Cambridge, Massachusetts. And we started mounting sensors on garbage trucks. And let me tell you, we discovered two things. One thing is only with 3 garbage trucks, we could collect data and scan every road in the city of Seoul at least once a week. That's quite impressive. Only 3 sensors moving there, it gets you a lot of data. And the second thing we discovered is actually by sharing data with cities, how we've been starting to deploy this in different cities, in Boston, in other cities. Here, with just a few sensors, you collect a lot of data about the city, and it becomes this idea of high resolution or hyper-local sensing. It can be air quality, it can be many other things. Incidentally, you find also very interesting mathematics in this. So this is a paper, if you're interested, that looks at something we discovered that I was telling you need very few vehicles to scan a city. Look at New York. On the x-axis, you got the number of